we're going to take a look at this. Divide that stuff using synthetic division. Synthetic division? What is this synthetic division? I will tell you. So it's very quick. It's very quick, and it's a lot more, I suppose, streamlined than polynomial long division. Hopefully, you make less mistakes, but it's really only convenient to use when you have a linear term here. Linear term? What does linear term mean? It means when you have just an x. No x squared, no x cubed, no x to the fourth, or whatever. It works the best, it's the easiest, if only you have an x with an exponent of 1, and maybe possibly a number there. Okay. So a binomial, I suppose. That's a linear binomial. Okay, well that's too many words. Too many words, man. I don't know what those mean. That's okay. So, what do I do now? I'm trying to divide that. All right. The first step, I'm going to do 2 examples for this. The first step is to write down the coefficients of the dividend with placeholders. Okay, so I have x cubed, x squared. I don't have an x term, so I need that. And then a regular constant. Okay, so I'll write down those, but I'm just going to take the coefficients, because with synthetic division, all I need is the coefficients. So I'll write it a little bit to the right side. -1, that's the x cubed. 4, that's the x squared. I need a placeholder, 0, that's for the regular x, and then the 9. Ooh, that's good. And then I put a little line, little box, little line there, and then here I divide by, well, this is x minus 3. We're gonna use a positive 3. You switch this side. Why do you do that? It's just because when you get this as a solution, later on we'll see this. If you get this as a solution, you would set it equal to 0. Actually, you've already seen this. You'd set it equal to 0. -3 equals 0. If you solved that, plus 3, x would equal positive 3. So actually, we're checking to see if 3, sorry, not -3, 3 is a solution to this polynomial. But we'll get into that later. So right now, maybe it's just best to think, okay, you take that number and you change the sign. Okay, what do you do with that? Well, you put it over here. I'm going to say this is going to be red, and I'm going to change the sign over here. This is negative, I change it to positive. If it was positive here, I change it to a negative there. All right, so then what do you do? Okay, now you start doing the synthetic division. It's very, very simple, actually. First step, bring that down. You don't have to do anything to it. Bring it down. Okay, that's great. Next step is to multiply. And this is how I'm going to multiply. It's important to look at this. And I'm going to put it there. It's like I'm bouncing a ball from up on like a ledge. And it's like, and it lands right here. That's not the sound that a ball makes, but I'm just going to multiply. 3 times -1. And then it lands over here. 3 times -1? Well, that's -3. Okay. And then here, I combine like terms. I just add or subtract. That's 4 minus 3. That's just positive 1. Sweet. Okay. And then I do it again. I do it same thing again. 3 times it, and then it lands right here. It's also still not what the sound a ball makes. And then I add or subtract. Well, here they're both positive, so I add. And if it's just 3, yeah. And then I multiply one more time. Still, I don't know why I keep doing it. I do know why, because it's fun. That's why. 3 times 3, that's 9. Great. That's 9. 9. Okay, and then I add those together, then I have a positive 18. This spot is important. That's your remainder. Remainder. Oh, you know, like the 12 remainders? Rudolph, Vomit, Blitzen, and Comet, and Cupid, and Vomit is not one of them. Reindeer, remainder? No? Alright, that's not funny. Let's move on. So, that last number is the remainder. Okay, watch the rest of this. That's actually the coefficients of the polynomial. This is how I write it. This is what I do. This is my constant term, so I just put a little dot just to remind me. No, that's my constant term. This is my x term. I'm just counting upwards. And this is my x squared term. So, my answer is going to be negative 1x squared. Why is that? I'm using that with the coefficients. It's positive 1 here, so I say just plus 1x or plus x. And then my constant term, plus 3. And then my remainder is just 18. In fact, all of your remainders for synthetic division, when we have a linear term, will just be numbers. It's simpler that way. If we just keep it like this, then our remainders will only be numbers without any variables. So let's see here. Plus 18. And remember, you divide the remainder by your divisor. We're dividing by x minus 3, so it's x minus 3. And that's super easy. That's super quick and it's nice and jolly. Everybody has a good time. I'm going to do another example, though, and maybe a little bit faster. So let me review the steps. First, you write down the coefficients of your dividend, whatever you're going to divide, making sure to put in any placeholders for missing variables and their exponents. So I was missing an x in there, so I put it in a 0. That's my placeholder. And then you take the opposite here, and that's just the trick we're going to look for right now. Later on we'll see why, or you already see why. And then you'll take the opposite sign and put her there. And then you're kind of like bouncing the ball. Now you bring the first term down, because there's nothing to add or subtract there. Bring the first term down, and then bounce, and it lands there. And then you add or subtract, and then you bounce again, and then you add or subtract, and then you bounce again, and then you add or subtract, and you get a remainder. It's amazing. Somebody thought of this. It worked out, and so they're like, wait, does it work out every time? And they kept doing a lot of stuff, and then they proved it, and they're like, yes, it works every time. But we're just going to use the fact that it works every time. Okay, way too much of me talking.